Hey everyone, welcome back. This is the third and final part of my three-part series on installing Arch Linux with Snapshot and Rollback support. Previously, we installed Arch Linux and set up Snapper for snapshot management. Now, what if your system becomes unstable due to an update, or you accidentally break it while testing new features? No worries, Snapshots let you restore your system in seconds. In this last part, I'll show you how to create, manage, and restore snapshots using Snapper. I will demonstrate 4 different ways to use Snapper. First, I'll show you how you can easily undo and redo packages installed by Pacman. Second, I'll show you how to restore a single file, such as a configuration file, in case you mess it up while configuring something. Third, I'll show you how to create manual pre- and post snapshots when testing changes, so you can revert everything if something goes wrong. And lastly, I will intentionally break my Arch Linux system, rendering it unbootable, and then show you how to restore the entire system within seconds, proving how effective Snapper is in disaster recovery. And also, in the end, I will re-enable hourly timeline snapshots, which I had disabled earlier, to automate system backups. So let's dive in. In this example, I will install a small package named Banner using Pacman. Once installed, I'll check the system to see what changes have occurred. I'll then try to undo the changes and see if I can restore the system to its pre-installation state. No snapshots have been created yet, so let's create one now. To demonstrate, I'll install a small package called Banner. This program displays text as a banner on the console. I'm using this small package for simplicity, but the same process applies to larger packages as well. Run the banner command to verify that the installation was successful. Now, check the snapshots. You'll notice that 2 snapshots have been generated, one before and one after the installation. The pre-snapshot preserves the system state before installing the Banner package, whereas the post-snapshot represents the state after the installation is finished. Now, inspect the system to see the changes made between the pre- and post-snapshots. In this scenario, you are looking at the differences between Snapshot 1 and Snapshot 2. These are the files that have changed between the 2 snapshots. Keep in mind that the displayed changes apply only to the root file system, specifically the root subvolume. Modifications in other subvolumes are not included. For instance, if a package installation affects the home directory, those changes will not be captured. To track changes in the home directory, you must create separate snapshots for it, which I will demonstrate later in the tutorial. I will now undo the changes made between snapshots 1 and 2. Now try running the Banner program again. As you can see, the Banner package has been completely removed and the system has been restored to its previous state. But I want to keep the Banner program, so I'll undo the changes again. This time is between snapshots 2 and 1. And just like that, I have reverted the system again, and my Banner program is back. Imagine you're setting up something and editing its configuration file. Then you realize you've completely messed it up. You want to compare your changes with the original file and possibly revert everything to its original state. Snapper allows you to undo not only all changes between 2 snapshots, but also restore a single file. Here I will make some changes to the nsswitch.conf file as an example, though the process applies to any file. Then I will compare it with the same file from snapshot number 2 to check what changes were made and see if I can fully restore it to its original state. So open the nsswitch config file, and I'll delete some random text. Save the configuration file and exit. Now compare the configuration file to the one in snapshot number 2. The number 2 in the command refers to snapshot number 2, while the number 0 refers to the current state of the file on the system. The output will show the differences between NS switch configuration in snapshot 2 and the current version. Lines starting with plus indicates these lines were added. They exist in the current file but not in snapshot 2. Lines starting with minus indicates these lines were removed. They exist in snapshot 2 but not in the current file. Now, if you want to undo all of the changes made to the file and return it to its previous state, run this command. Check the configuration file again. And as you can see, the file has been successfully rolled back. In this example, I will walk you through manually creating pre- and post-snapshots. In example 1, I demonstrated how these snapshots are automatically created when installing packages with Pacman, allowing for easy rollbacks. However, not all modifications trigger automatic snapshot creation. You might want to test different themes or settings, and if the results aren't satisfactory, you may prefer to revert them. Similarly, if you're following an Arch Wiki guide that presents multiple ways to achieve the same task, you may want to experiment with each method before settling on one. Or perhaps you're following an online tutorial but are uncertain whether it will work correctly on your system. Without Snapper, the fear of breaking your system and the hassle of fixing it might stop you from experimenting. With Snapper, you can manually create snapshots before making changes, ensuring that you can always restore your system if needed. This lets you test configurations freely, knowing you have a safety net. In this example, I'll show you how to create and use manual pre- and post-snapshots to ensure your system remains secure before making major modifications. I'll begin by manually creating pre-snapshots of the root and home BTR-FS subvolumes. Next, I'll clone the NetHogs package build from the AUR and then build and install it. Once the process is complete, regardless of whether it was successful or not, I'll take post snapshots for both root and home. I'll then compare the system changes between the snapshots and revert everything back to its original state. So first, create a manual pre-snapshot for the root subvolume, snapper-c root, the name of the snapper configuration for which this snapshot will be created for. In this case, it is root. Create -t pre specifies the snapshot type as pre, meaning this snapshot is taken before making changes. -c number enables numbered snapshot cleanup. Snapper will manage and delete older snapshots automatically based on configured policies. And the description. Now check the snapshots. As you can see here, a pre-snapshot has been created for the root subvolume. Do the same for the home subvolume as well by creating a pre-snapshot. Check the snapshots for home. A pre-snapshot has been created for the home subvolume as well. With pre-snapshots created for both root and home, you can now freely install or experiment with anything. Before compiling the NetHogs package build from the AUR, I will install the necessary prerequisite packages. Clone the NetHogs package build from the AUR. change to the nethogs git directory, build and install the compiled package. The installation of nethogs package is now complete. Run the nethogs program to confirm that the installation was successful. nethogs is a lightweight command line tool for monitoring real-time network bandwidth on Linux. Unlike traditional tools that categorize traffic by protocol or subnet, nethogs tracks bandwidth usage by process. If you notice a sudden surge in network traffic, you can run nethogs to identify the process responsible and terminate it if necessary. Now that nethogs has been successfully installed, or even if the installation had failed, it doesn't matter. I have finished experimenting with it, so I will now create post snapshots for both the root and home subvolumes. First, I will create a post snapshot for the root subvolume. The snapshot type is now set to post. Pre-number, the reference number of the pre-snapshot associated with this post snapshot, which is 3. And the description for this post snapshot. The post snapshot for the root subvolume has been successfully created. Now create a post snapshot for the home subvolume as well. The pre-snapshot reference number associated with this post snapshot for home subvolume is 1. The post snapshot for the home subvolume has also been successfully created. Now take a look at what has changed in the system by comparing the pre and post snapshots. And these are the files that have been changed. A total of 28 files in the root subvolume. Now take a look at what has been changed in the home subvolume by comparing its pre and post snapshots. And these are the files that were changed in home. A total of 255 files. I have wrapped up all the experimenting and determined not to keep nethogs just as an example, so I now want to undo all the changes and restore the system to its previous state. So undo the changes made in the root subvolume. In the same manner, undo the changes made in the home subvolume as well. Check whether nethogs has been completely removed. And as you can see, nethogs has been entirely removed, including the directory cloned from Git. Depending on the installation method or previous changes made, you may also need to log out and log back in to fully revert all modifications. Since you have removed the NetHogs package, there is no need to retain its pre-post snapshots if you do not plan on using it again. So you can go ahead and delete them. In this final example, I will demonstrate how to restore a snapshot using the GRUB menu. To do this, I will delete some of the most essential files and directories that Arch Linux depends on to function. These include the Linux kernel and initram fs files located in the /boot directory, the /etc directory that stores all configuration files, and the /user directory, which contains drivers, kernel modules, and essential libraries. After deleting these crucial files and directories, the system will become unusable, preventing me from executing any commands. The next boot attempt will inevitably fail since the OS will no longer be functional. At that point, I will force a hard reboot and attempt to recover the system by rolling back to a previously working snapshot. So before I delete them, here's how they appear. Now I'll delete all of the files and directories recursively. All critical files and directories have been deleted, and Arch Linux is now completely broken. Nothing functions anymore. So I will perform a hard reboot of the computer. As expected, the system fails to boot and an error message is displayed. So return to the GRUB menu and this time boot from snapshot number 2. Check the boot directory, and as you can see, kernel and initram fs do exist. Open the btrfs assistant. Go to Snapper tab and then to Restore. Select snapshot number 2, and then Restore. Select Yes, and then OK. And then Reboot. As you can see, the Snapshots menu is no longer visible. This happened due to the rollback, but don't worry, we can resolve this issue once we boot into the system. Your system has successfully been rolled back and is now in its original state. Now check the system once again. and everything is exactly as it was before. Check the boot directory. The kernel and init RAM FS are properly restored as well. Now, make sure to update the grub.cfg file so that the grub menu snapshots remain in sync. With the configurations and demonstrations finished, it's time to turn on automatic timeline snapshots. When enabled, a snapshot is created every hour, and once a day, older snapshots are cleaned up using the timeline cleanup algorithm. By default, timeline snapshots are enabled for both root and home, but it's recommended to enable them only for the system root and disable them for the home directory. Enable Snapper Timeline Timer. And then enable Snapper Cleanup Timer. That's all. Every hour from now on, a single snapshot will be created and cleaned up every other day. Well, that's it. You've successfully set up Arch Linux with full rollback support. If this series helped you, show some love by liking, subscribing, and leaving a comment. Until next time, take care and happy computing.